The following question was asked from C programming and it was asked for 1 mark. Basically, we need to write the function for clarity like this: int g, int p, and inside this particular function we are having printf %d p, and then we are returning to p, right? And thereafter one more function is there, int h, that is int q, which is as a parameter, and inside this function we are having two further statement, that is printf %d and g, and thereafter we will return q, right? So you can understand this particular, this is a function, this is one function, and this is another function. This is two separate functions, right? So I can give name, let's say it is further function 1 and it is my function 2, right? Now from main function onward, our function will execute g10 and h10. This function will call its parent function, which is this. Here in this parent function, gx will be called. So gx means it will map to this function. So this function will go to here and it will call it. So after that, if you will see here, it is calling to 10. It is calling to 10 because x is going to hold eventually the value which is a parameter here, and it will return, it will print the value of p, that is 10. After that we are returning p, that is we are returning what? We are returning x. Ultimately we are returning this x, means we are again coming back here. After that we are again at hy. So when I will be at hy, I will call the mapping function for this, that is this y function, which is corresponding to h. Now when I will call this function, I am returning the value of g here. What I am returning? The value of this function, that is q here. Inside that we are returning g. Inside that we are returning g, but it's q. It's not g, it's q. We are returning q, right? It's q. So we are writing the value of q, that is we are going to print 20. And if we are going to return 20, thereafter we are calling q. That means we are again coming back to this function. So after that, you can see that now as g and h both function will return 10 and 20 respectively, right? So now f10 comma f10 comma 20, because ultimately it will return like this, f10 comma 20 will be called from here, and then again g and h will call 10 and 20 respectively. So 10 and 20 will be again print respectively. So first g is printing, and thereafter we are printing the value of h, right? So as a part of this, if you can see, then 20 comma 10 and then 10 comma 20, that is option A will be the correct answer for this. Okay, so you need to be very careful because it is just map. We need to map the function accordingly, because here if it is g, we need to go to g, and here we are printing p. If we are returning to h, we are returning to this function and we are returning q. So we need to maintain the order. Here we are returning to x, here we are again returning to the function from where it is called, right? So option A, 20 10 10 20 will be the correct answer for this. The following question was asked from programming in C. The following question was asked from programming in C. The function is given like this. Int fx equal to character star a. The concept they are using is a pointer. Character star b equal to a, they are assigning the value of a, which will be passed to this function, to the character star b. And while star b b plus plus, the value of b is going to increment, and finally return b minus a. Which of the following statement is true? So option A, the function called fx abcd will always return a value. So yes, it will always return a value. It is not given anything else. So definitely nowhere there is an error. 101% it will always return a value. So A is the correct answer. Option B, assuming a character array C declared as C equal to ABCD in main. So if we are going to declare ABCD, the function called fxc will always return a value. Obviously 101% it will always return a value, because at the end we are returning something like B minus A. So always it will return a value. So it is also a true. Option C is the code of the function will not compile. So it is false itself. It is contradicting option A and B itself. This particular option C is contradicting option A, B, because already it is something written. Obviously the compilation is the before process of execution. So it is false. And option D is assuming a character array C is declared as character star C equal to ABCD in main function, the function called fxc will always return a value. Yes, it will always return a value, because every time whatever we are going to pass it as an input, it is going to be assigned to the character pointer variable B. And after checking, obviously if there is an input, the while loop will always be true. It will increment the value and it will definitely return a value. So option A, B and D is the correct answer for this question. It was asked for 1 mark. I hope it is clear. The question is, what is the output of the following C program? And it was asked for 2 marks, right? The question along took the concept of pointers, right? And if you can see here, we are using the data type double. So what we are doing, double A equal to this data set is given, and thereafter pointer is defined star P star Q. They are two and double pointer. They are double pointer. The data type is double. They are not integer data point. They are double data point. And further we are assigning the value of A to P and P plus 1 to Q. Print %d int Q minus P int star Q minus star P. So if you can see here, if you can just see here, then first what will be happen, that we are having one value that is 20.0 and 25.0. So we are initializing an array with two double values like this. We are initializing the array with two double pointers, right? Two double values. After that, the double pointer have further declared star P and star Q. So these two pointers P and Q created here, these two pointer P and Q created here, which are declaring two pointers as a double data type. Third, what we are doing, we are assigning P equal to A, right? So we are assigning the address of first element to array A. What we are doing, assigning the address of first element, assigning the address of first element to array A to pointer P. Ultimately this will hold P will hold address of first element, that is A, right? And after that what we are doing in the fourth step, we are just doing Q equal to P plus 1. Q equal to P plus 1, right? So we are just assigning the next address of that pointer to Q, that is this particular part 25 ka address, 25 ka address we are just assigning to this Q. After that what we are doing, if you can see here, int Q minus P, int Q minus P. So if we are going to print Q minus P, it simply means that we are subtracting their indexes. So some one element, that is 20 is stored here and 25 is stored here, right? So 20 is stored here in double format, 25 is stored here, and we are subtracting their indexes. Obviously there is a one index difference, because the next element is just at the next place. The next element is just at the next place. So the difference of their indexes will be 1. And star Q minus star P means the value subtraction, that is 25.0 minus 20.0. The value associated with star Q, that is this. The value associated with star p is this, that is 5. So 1 comma 5, option B will be the correct answer for this question. I hope it is clear. As question was asked from pointers topic for 2 marks. I hope it is clear. The following question, you are given a set V of distinct integers, a binary search tree T. The question was asked from programming in C and data structure, and the topic is tree data structure. Inside tree we are using BST, binary search tree, and the question was asked for 2 marks. So a BST is created by inserting all elements of V one by one. Starting with an empty tree, the tree T follows the convention that at each node, all values stored in the left subtree of the node are smaller than the value stored at the node. You are not aware of the sequence in which values are installed into T, but you do not have access to T. Which one of the following statement is true? Which of the following statement is true? That in order traversal of T can be determined from V. Root node T can be determined from V. Pre-order traversal can be determined from V, and post-order can be determined from V. We are not aware of all the elements of V. We only know that it is a BST. And tree follow the convention that all values stored in left subtree of the node is smaller than value stored. It means values which are stored in left subtree format. We are only aware of it. We are not aware that conventionally which sequence will stored in which tree. So what I can take, basically there is a property that you can write or you can make it as a note, that in order traversal of a binary search tree, that is BST, gives the sorted tree, right? Gives the sorted tree. Okay, as it will traverse left root right, as you know, as it will traverse left, thereafter root, thereafter right, right? And also we are having here the set V, also what we are having, set V. So we can arrange this in increasing order. We can arrange them in increasing order. Once we can arrange them in decreasing order and derive the in order traversal for it, we can derive in order traversal only. But we cannot derive what is the root order, what is the root value, what is the pre-order, what is post-order. Because if any binary search tree is given, then in order traversal is nothing but the ascending order of that. What is, if any binary search tree is given, then there is a property that the ascending order is in order. So using the data, we can say that only in order can be derivable, but B, C, D, root, pre-order, post-order cannot be derivable. So option A is the correct answer for this GATE question. I hope it is clear. Was a part of programming in C and data structure, and the question is like this. So I am reading from the starting. It was asked for 2 marks. Consider an array X that contain n positive integers, A subarray of X is defined to be a sequence array locations with consecutive indices. The C code snippet given below has been written to compute the length of longest subarray of X that contain at most 2 distinct integers, right? The code has 2 missing expression label P and Q. Here something is missing P and here something is missing Q, right? And this is the code which is given. The question is expanding like this. Which one of the following option gives the correct missing expression? Hint, at the end the ith iteration, the value of len1, that is the length of longest subarray ending with xi that contain all equal values, and length 2 is the length of the longest subarray ending with xi that contain at most two distinct values. Four options are here, and we need to uh, keep answering that what would be the correct option p of p, and what would be the correct level that should we give to the q here. Question was for 2 marks. So here you can see that for loop is here, and as per the question, two sub arrays will be like this, right? Two sub arrays will be like this. Now first will store the second distinct value, the first will store the second distinct value, right? And second will store the first distinct value, right? And second will store the first distinct value here and here. On going through code, if you can see the for loop, for I equal to 0, I less than n, I plus plus, we should incrementing the value of length 1 and length 2. We need to keep incrementing the value of length 1 and length 2, right? Now coming to the conditional statement, here xi equal to second, and here second, here xi equal to second, and here length 2 is equal to greater than max length. So coming to this conditional statement in if else, so here and here, as per the hint which is given, you know, it is the hint which is already given. If you already read it, right? So as per this particular hint, if the current digit is not the same as per the previous digit, if the current digit is not same as per the previous digit in the subarray, we should reset the value of length 1. We should reset the value of length 1, right? And we need to increment the value of length 2 in that case, correct? If another way is here, if we go to else, that if the alternate is, if the part is like alternative, in that case we should have to increment the value of length 1, and length 2 will be increment by 1. Length 1 will be increment, and length 2 will be increment, and if it is not going to match with the value, we need to make incremental increment in the length 1 plus plus, and one is length 2 plus plus. If length 2 is not matching with the previous one, here length 1 is not matching with the previous one, right? So what should I place here on the place of p, so that length could be increased? So here you can see, I want to increase the length first. What I want to check, that we should have to reset as per the thing. We should have to reset the value. So if I want to reset the value, either B or C will be there, because I need to assign P equal to 1 anyhow, right? Because already it is given that at the end of ith iteration, if the value of length 1 is length of longest ending, then and length 2 is subarray that contain two most value. But if it is not so, then we have to reset it. So ultimately the P will be 1. So A is cancelled and D is cancelled. And if this is not matched, anyhow, if this is not matched, so P is ultimately what? P is ultimately, I need to make 1 here, length 1 equal to 1, and length 2 equal to what? Obviously I will assign length plus 1. Already the I think already the information is given in the question itself. If length 2 is not matching, just add length 1 plus 1. So already the information is given in the question itself here. If here it was length 1, I will make length plus 2, right? So using hint itself, we can say that option B is the correct answer, that P will be 1, Q will be length 1 plus 1. We need to read this particular hint very, very carefully. All the information is hidden itself. So anyhow, option B is the correct answer for this question. P1, length 1 plus 1. I hope it is clear. The following question was asked from stack data structure for 2 marks. Let S1 and S2 be two stacks. S1 has capacity of 4 elements. S2 has capacity of 2 elements like this. S1 already has 4 elements like 100, 200, 300 and 400, whereas S2 is empty, as you can see in the diagram itself. Only the following 3 operations are available, and what operations we can perform? We can push to S2, means we can push some elements to this S2 and push to S1. We can further push some element from S2 to S1. So first operation we can do this, second operation we can do like this, and third operation is generate output, means we can print the topmost element. This is the third operation which is allowed, right, from S1. Now, not that the pop operation is not allowed on an empty stack and push operation is not allowed on a full stack. That is simple stack property is given. Which of the following output sequences can be generated by using above function? Which can be generated? Which can be possibly generated? It is the important question. So if you can see option A, in any case I cannot generate option A. Why? Because I need if I want to get 100 at the first position, it means that I should have this particular position at the top. Now if I will pop this 400, I will put here. If I will pop this 300 also, 300 will be here. In any of the case 100 cannot be there in the front position, because it is not possible using operation 1, operation 2, operation 3, because 100 cannot be there at the topmost position, because using 1 2 3 we cannot make this element at the topmost position. So at the topmost 200 can be there, 300 can be there, 400 can be there, but 100 cannot be there in any of the possible cases. As you can understand, further there is no capacity for S2, so that I can put 200 also here. So option A is get cancelled. Option A get cancelled. Now option B, can 200 be there? Yes. Now if I will just push these two elements one by one, and I can have 200 here. So that is possible. After that 300 possible? Yes. I can put this 300 here now, because 200 remove, then 300 I will use the operation number 2, 300 will be here, and I will use operation number 3 to print it. So it is possible. After that 400, yes, again I will, this is already popped off and printed, so I will again push this S2 to S1, that is operation number 2, and I can print 400, and at the end 100 will be printed. B is 101% possible. Now option C, is this possible? Yes. See here, initially 100, 200, 300 and 400, and let's say one more stack is here. So we are just directly printing 400, directly popped off without putting into S2. S1 it is S2. Possible. Thereafter 200, yes. What I will do, this 300 I will push here, and directly I will pop this 200 from top. Thereafter 100, yes, because right now the array is only having 100. It will be printed, and then 300, yes, I will use operation 2. It will be pushed to S1 and top element will be written. So option C is also correct answer. Now option D, can we print 300 first? Yes. Again let's see the example. 100, 200, 300, 400, and one more stack I am having which is empty. It is S2, it is S1. I want to print 300 first. I will use operation number 1. 400 will be here. Thereafter operation number 3, 300 will be popped off and printed. Done. Then 200 already on the top of the stack. So what I will do, I will directly print by popped off. Done. 400 which is in S2, use operation number 2, push S2 to S1, top of the stack, it is 400 now. Use operation number 3, popped off and printed, and then the only remaining element 100. So ultimately option 1 is not possible, but here option B, option C and option D are the possibility which can be the output using the property of 1 2 3 stack property. So this was asked in 2 marks from stack data structure. B, C, D is the correct answer for this GATE question. I hope it is clear. The following question was asked from tree data structure, and the subtopic is minimum spanning tree for 2 marks. The nature of the question is NAT, numerical answer type. The question is the number of distinct minimum weighted spanning tree for the following graph is how much? We need to make a minimum spanning tree. For making a minimum spanning tree, we may use Kruskal's algorithm or we may use Prim's algorithm. We can use any of the algorithm, right? Using any of the algorithm, let's say if I am using Prim's algorithm, because at the end I will get connected path. So all the minimum weighted path 1, 1, 1, 1 I will choose, because till it don't make cycle. We can free to use minimum weighted. A, B, it is 1. A to F, it is 1. It is done, no worry. After that I can use E to D, that is 1, and thereafter D to C, that is 1. It is possible, right? Now if you can see here, after this is covered, then what is the next minimum edge? That is 2. After 1, 2 is the next minimum edge. So for that I can take any of the possible edge, this 2, this 2, or this 2, or this 2, or this 2, or this 2. So many edges are here. We do not need to go to 3. So I can use 2, that is G is here. So I can use this 2. Let's say I am connecting this like this, which is having weighted 2. Now cycle should not be made. Cycle should not be made. Cycle should not be made. Now how many possibilities are there from the edges A, B and F? There are 3 edges A, B and this particular F. And from this I need to decide what are the various possibilities. So one possibility is like this. F, A, B, G, E, D, C. This is one of the possibility. And for that also I can use any of the possibility from here. So this is one of the possibility. Another possibility is this B, A. This is the second possibility, and this is the third possibility. Right or not? This is the third possibility, because in all the cases cycle is not going to form, because we are going to use this or this. And for each again we are having 2. So you can also go with any of the 2, like this or like this. Right or not? So ultimately the edges A, B and F will ultimately decide how many possibilities are there from each edge. So basically there are 3 possibility from each edge in the sequence term, because we can write it in the 3 format: BF, BAF, or FAB, or ABF. So 3 possibilities plus 3 possibilities plus 3 possibilities. Ultimately total 9 number of minimum spanning tree we may get. Means this 9 spanning tree which is minimum will have equal weight. And what would be the equal weight? That would be simply calculated as 1 plus 1 2 plus 1 3 plus 1 4 plus 2 6. All these 9 spanning tree will have 6 weight. But here weight is not asked. Here only the ask how many minimum weighted spanning tree. So minimum weight is 6, but total number of possibility is 9. So 9 is the correct answer for this GATE question, which was asked for 2 marks from tree data structure. I hope it is clear.